Hi guys, welcome to my channel. Today let's all letter the lead code question. The description of the question is as follows: that we were given a string S. We need to return the size of longest substring containing each vowel an even number of times. So let me just write some note points. We need to return the longest substring which is containing the vowels even number of times. So this is the question that's given to us, and we also knew that substring, if we considered any start index and any end index, so that's 0 is less than or equal to start index is less than or equals to end index is less than or equals to s dot size minus 1. If we consider any start index and end index, and if we consider the subarray from that start index to end index, then everything would be considered as subarray. So if our size is of s dot size is, let's say, n, then the total number of substrings available are n into n minus 1 by 2. So how we could prove that is very simple. So if we just consider a b c d, then a itself is a substring, b c d is itself a substring, followed by ab, ac, ad, bc and bd, cd, followed by abc, ab is a substring. Sorry, I just need to find the substrings, right? So here ab is a substring, bc is a substring, cd is a substring, abc is a substring, bcd is a substring, followed by bcd. Sorry, abcd is it's also again a substring. So if we just had a count of this, then this would be 4 and 7, 9, 10. So if n is considered to be 4, it would be 4 into 3 upon 2. Sorry, it's n into n plus 1 by 2. I'm sorry for the error. So that's 4 into 5 upon 2. So that's exactly equal to 10. This should be 4 into 5 upon 2. So that's how it should work. And given n is of order 5 into 10 power 5, so if we just try considering every substring of it, then it would be 5 into 10 to the power 5. So 10 to the power 5, for example, I am representing it with tilde. I'll just, for your information, 10 power 5 representing it with tilde, n into n plus 1. So n would be 5 into tilde, 5 into tilde plus 1 upon 2. So if we just consider 5 into tilde and 5 into tilde, that's almost 25 into tilde square, and tilde is 10 power 5. So 10 power 5 whole square would be of order 10 power 10. So this would be out of bounds if we try solving it by brute force approach. So we need to find any optimal solution for solving this problem. And the optimal solution is, here you could see, I'll just write some general observations. In this question, there is no, or I would just specify that there's no constraint on the odd number, and the constraint is only for, constraint for consonant character, and the constraint is only for the vowel character. So what I'll specify over here is, we knew that we need to check if our number of vowels are even or odd. So for achieving this, we already knew that this could be achieved by an operator, and that operator is an XOR, because if you just specify 1 XOR 1 or 1 XOR 1 or 0 XOR 0, in either case both of these will give us a result 0, specifying that we have even number of characters, because 1 means there are two even characters or even vowels, so that would give us 0. But if there's 1 XOR 0 or 0 XOR 1, in that case we'll get 1, specifying that we are having only one one vowel character or odd number of vowel characters. In the other way, if we do have 4 E's within a given string, then it would be 1 1 1 1, and ultimate XOR would be 0. So in this case we are specifying the number of E's in this string are 0, but we have how many vowels? We do have 5 vowels. So if we do have 5 vowels, then for each vowel we do need a parity. So what do you mean by parity? In the sense, parity is nothing but the bit that helps us to identify which character is the current one. So if we do have A, E, I, O, U, I'll just give my parity to A as 1, to E as 2, to I as 4, to O as 8, to U as 16. So one might question me, why not parity 3 would be given to I, why only 4? So for this, I'll just explain you with the help of a clear example. So if you just consider 4 bits, binary bits, 0, 0, 0, 0, or I'll just consider 5 binary bits. So if in order to find out whether A is odd number of characters or even number of characters, we just need to consider one bit without affecting the remaining bits. If we affect remaining bits, then in the other way we are specifying that if A is changed, then we are playing with the count of E as well, but we shouldn't do that. We should only play with one bit at a time, and that depends upon parity that we assign to the number. So if we just consider A, then that would be one, it would be A, this is A. So for E, what I'm just playing with one bit again, that's this bit. For E, if I specified 3, then it would be this way. So I'm just, if a character I is occurring, then I'm saying that I'm changing the counts of A and E as well, but I shouldn't make that happening, right? So in that case, my 1 would be here. So 1, 2, 4 and 8 would be O, U would be 16. So that's how it should work. And for every other character which is not we already knew, I'll also specify this other condition, which is the property of XOR. I'll just call it other property of XOR is X XOR 0 is always equivalent to X. We do have here parity bits only set for even numbers, but for odd we do not have, for vowel characters, for consonant characters we do not have any such constraint. In that case, for every consonant character, the parity would be set to 0, because that wouldn't be affecting our XOR anyway. So I'll just call vector in parity setter, I'll just call parity. We do have 26 English alphabets, so 26 zeros initialized with, but for A, E, I, O, U, I need to change it, right? So parity of A minus A. So what this would be happening is, what I'm specifying here is, so a subtraction operation would always be performed between two decimal numbers, right? So here this A would be converted to ASCII value. ASCII of A, I'll just show you ASCII table. So this is the ASCII table. So if you just consider here, we could see small a corresponding decimal value is 97, right? So small a's corresponding decimal value is 97. So we'll just specify 97 minus 97 would be equal to 0. Why we are subtracting this a is because a is the base for everything. So in order to specify, if in English alphabets, what we would say is D is my 4th letter, right? So in order to specify that 4th letter, I know that this is having ASCII decimal value as 100, but I also know my base character A is having 97, but we are following 0 indexed array. So in other sense, my D will be third character if we just follow 0 indexed array. So if I just subtracted this 100 minus 97, then I would get that 3, right? So that's what I'm doing here. I'll just copy this for E, I, O, U as well. This is for, I'm sorry, I guess it's not properly copied. So this is E, I, O, U. So this is E, this is I, this is O, this is U. So here this would be set to 1, this would be set to 2, this would be set to 4, this would be set to 8, this would be set to 16. So that's how it should work, and remaining everything would be 0. So now having this done, what I'll specify here is, so if I just considered, these are my parity bits, right? So if anyhow my answer is 0, in the sense that my XOR is 0, if my XOR is 0, that specifies if my XOR till at is 0, in the sense that my all characters are 0, all these values are 0, in the sense that all my oval characters are present even number of times, then simply I could consider the longest string, right? Or the index that currently I am at. So I'll just call an n to be s dot size for int I equal to 0, I is less than n, I plus plus. I'll just explain you what I'm trying to do over here. I'll also keep a track of unordered map. Why I'm using this unordered map, I'll just explain you in a second. I'll just call it checker. So here what, I also need to keep the track of my XOR value, right? Int XOR is equals to 0. So what I'll do here is, and after this I'll also specify my checker of 0 is equals to -1. I'll explain you why I'm doing all this. So XOR, first if I simulated this or with the help of this example, then it would be clear. So first I'm writing what I'm thinking of, and then I'll explain you what I'm trying to do. So after that I'll just need parity of I'll just call char ch as well here. Char ch would be equals to s of I parity of ch minus a, or I would just call here XOR equal to parity of ch minus character a. So that's how it should work. And if I'm just checking if my checker dot find XOR is equals to checker dot n, in that case I'll just specify my checker of XOR value should be equals to my index, that's I, else I'll just call an answer as well. Initially my answer I'll just call it to be 0, and here answer would be equals to what? Answer would be equals to maximum of answer followed by I minus checker of XOR. I'll just return answer. I'll just explain you what I'm trying to do over here. So I'm not sure why this was happening. So I just written a spelling error here. I'm sorry for that. That should be parity, not party. And XOR, okay, XOR itself is an operator, so I need to make it XOR val. So I'll just make it XOR val. I'll just call XOR val here as well, and XOR val here as well, followed by XOR val here as well. I'll just try running this out. So it's working as expected. So I'll just explain you what I trying to do over here. I'm pretty sure you might have understood why this parity is being set for even numbers. I explained you the intuition for this here as well. So after having this, I knew if I just consider my example to be E, L, E, E, T, M, I, N, I, C, O, W, O, R, O, E, P. We do not have any constraints on consonants. So just keep a track of that. And why this XOR value will be using is fairly simple. See, what I am trying to do now is fairly simple. So first of all, my first character is E. So my XOR value would be 2. So here XOR value would be 2 until and unless my XOR value is not equal to 0, in the sense my XOR value is 2. In that case, till this substring I couldn't find any substring that's having even number of vowels, right? Followed by L, again XOR would be 2 because 2 XOR 2 would be 2, and here 2 XOR 2 would become 0, right? So here my XOR is 0. I am specifying that till this character I could find a substring that's having even number of vowels, right? That's why my XOR is 0. But initially I just meant to say that initially my XOR is always 0, right? And I'm following a zero based indexing. So I'm just specifying that initially my all elements XOR would be 0 only, and that value I'm initializing with -1 because see, now here I just found XOR value to be 0, in the sense that from here till the starting point I do have valid answer or fruitful answer. In that case, I'm just using a zero based indexing. So if I used a zero based indexing, then this would be 2, right? 2 minus 0 would be what? 2 only. But I need answer as 3 because we are using zero based indexing. That's why it's initialized with -1, in the sense that 2 minus of -1 would be considered and answer would be 3 in that case, right? So I'm just checking if my XOR value is till this point I guess everything is right. So, and again I found a 2, right? If I found a 2 again, what I'm doing is again I'm XORing, and this is again 2. So now what I'm trying to do is I'm trying to store this within a map. Why this map is useful? Because this map helps us in understanding till what previous point the XOR value is same, so that from that XOR point to current XOR point everything should be 0. That is the only case when two XORs will become equal. In the other sense, I'll explain you what I'm trying to say more clearly now. See, so if I'm just finding my XOR value is not present, right, that's when it would be reaching the end. In that case, I'm just making my checker of XOR value to be equal to index. So now I minus checker of XOR value. So what's my current index in this case? 0 1 2 3, right? 3 minus, and what is the checker of XOR value in that in the earlier case? It would be 0 again. So 3 minus 0 would be what? 3 again. And how I'm getting that 3 is because of this. I'm pretty sure you might be confused over this point, so let me just explain you. So what I'm specifying is, see, here my XOR value is 2, here also my XOR value is 2. In the other sense, from this point or to reach to this point, my XOR value is 2. In the other sense, in between, I'll just specify. So here if it's A XOR B, and here if it is A XOR B XOR C, and here if it is A XOR B XOR C XOR D. So I'm just specifying that my A and this A XOR B XOR C, A and this A XOR B XOR C XOR D values to be equal. So if A is equals to A XOR B XOR C XOR D, that will be only possible in one condition, when B XOR C XOR D is equals to 0, and that's only seen here. 2 XOR 0 XOR 2 is 0. So I could just consider this string as well. So that's where this XOR value is helping me. So I'm just finding if my XOR value is not present. If that XOR value is already present within my map, in that case my next value, in the sense that the index that I stored in the map value, the next character of it till the current character, all will be XORing up to 0. So if that is XORing up to 0, in the sense that my substring is containing even number of characters, in that case I could simply use my I, current index minus checker of XOR value. So that's how I'm doing it. I'll also specify my C++ compiler not to import any libraries from C. That will be helping me to take input or give output anything to the terminal. So that's how it should work. I feel it's going to work. So let me just specify, do not tie anything or in the terminal, or do not tie output to the terminal. So I'll just try submitting this out. It should work as expected, but this should be 2 : I'm sorry for that. So everything is working as expected. Let me just try submitting this out. Yes, we bet 60% people with our complexity. Feel free to add anything in the comment section if you think anything is unclear. Thanks a lot for watching the video.